Okay, hello class. Ito yung na-miss nating chapter last Tuesday. Kasi may mga inasikaso ako sa DPSM. Okay, mga urgent things. So, let's continue. Ito na yung last chapter for the second exam. Ito na yung last coverage for that exam. And as you can see, ito ay energy and power in digital circuits kasi we have studied circuits na nagbabago in time. So, nagbabago yung voltage, nagbabago yung current. So, now, kailangan natin malaman kung paano ba natin calculate yung power and energy now that things are time varying. Okay? So, yeah. Let's do this. So, kung maiisip natin, no, at some certain point in time, let's say time t, alam natin that the equation P is equal to VI must hold. Okay? So, ganun pa rin. Wala namang bago na the power is just multiplication of V times I. Okay? And however, this time around, kailangan lang natin na yung power at time t must be equal to the voltage at time t times the current at time t. Okay? Straightforward naman. And then, ang implication lang dito is that ayun, dapat alam natin yung mga voltages and currents at certain times. Okay? So, yan. So, let's try to do this simple RC circuit. Yan, simple RC circuit. Then let's try to calculate the power na dinidissipate mo. So, pipili tayo, kailangan natin pumili ng element na titingnan natin. So, for this example, tingnan natin yung dinideliver na power ng source natin, the voltage source. So, that would be given by P of T must be equal to the voltage is giving. So, V lang lagi yung binibigay niya. So, we have this and then the current I of T. Okay? So, kinuha natin to kasi gusto natin tingnan yung kaya niya ibigay dun sa buong circuit. Okay, and then alam naman natin na voltage here won't change. So that makes our calculation much easier. Okay, and then the current. We know the current here has to be dependent on the capacitor, di ba? Okay? Okay. Now, once we close the switch, makukuha natin, magkakaroon ng current bigla. So, I of t, alam natin si I of t, would be simply node analysis lang. V minus VC, V minus VC, which is, alam natin si VC ay dependent on the time. Hindi natin lalagay yung dependency on time. Divided by the resistance R. Straightforward naman, di ba? Bago. And then, from previous examples, alam natin na yung charging the capacitor would give you this equation. 1 minus E is negative T over RC. For a simple RC circuit. Okay? All right. Now, let's just combine things. Let's just combine things. We can see that P of T now becomes apparent to us, which is V minus V minus 1, 1 minus E, that is T over R C. Then all over R. Okay? Over R. And then this is just V of T. Let's just simplify a little bit. No? This is V minus V plus V e raised to negative T over RC all over R. This cancels out. Then I have V over R, V raised to negative T over RC. Okay, may na-miss tayo. somewhere along. Okay. So, times V pa pala nung everything, no? So, hindi naka-ano lang natin. Miss out lang natin. Okay, so dapat ito ay V squared. V squared. Okay. So, this is V squared, V squared, V squared, V squared. Okay, yan. Tama na. Okay, miss out lang natin yung multiplication ng V. Okay, so this is the power delivered by the source at the time that switch closes. Okay? So pagka sarado ng switch natin, pwede ni-dissipate na siyang ganitong amount of energy power. Okay, so now at tanong naman natin, what would be the energy that this source is giving off? Okay, so therefore power, integrate lang natin siya from 0 to the time that we are concerned with. Okay? So, sabihin natin at 1 second or etc. Di ba? Pero pwede naman natin tignan at infinity. Tignan natin mamaya kung ano yung mangyayari pag infinity. Actually, ayun yung gagawin natin. So, let's do this. You just plug in what we have solved. 0 to infinity. So, kukunin natin ngayon total power na ginigive off nung source natin. V squared over R. V squared over R times e raised to negative t RC. And then dt. Okay? This is fairly simple. We just have to labas lang natin si V squared over R and then integrate natin si e raised to negative t over RC. So, magkakaroon tayo ng factor ng negative RC. Tama? Kasi may madidivide to by negative 1 over RC. So, ayusin lang natin. Magbabaliktad din yung ito ilalabas. Okay, and then you're left with e raised to negative c over RC. Integral niyan, same lang, di ba? Kasi exponential lang naman siya. Then we go from 0 to infinity. We evaluate this guy. So therefore, the total energy that has been done is negative v squared. Negative v squared c. Negative v squared c. And then this is evaluated at infinity. That would make this first term 0. Then evaluated at 0 gives me 1. Therefore, this is just cv squared. Okay? Okay, so that is the power, that is the energy that is given off by that is being delivered sa lahat ng elements dun sa nakadikit sa source natin. Okay, tingnan natin yung alam natin na yung energy na i-store ng capacitor mo is 1/2 CV squared. CV squared. Okay, so may kinukuha siyang 1/2 CV squared galing doon sa battery, doon sa source natin. Okay, so ito yung binibigay na total ng battery. Ito naman yung kinoconsume ng capacitor. So, goes to capacitor ito. Okay, and then by inspection, alam na natin na 1/2 CV squared din sa 1/2 CV squared din sa resistor. Kasi, di ba, minus mo lang naman to dito. Minus mo lang siya. Nalalabas natin sa resistor. Pero let's try to calculate. Let's try to calculate that. This is fairly easy kasi alam natin na yung power through the resistor is just I squared R. Diba? I squared of T times R. Okay? And then we know I squared to be this guy. So let's try to write things down first para di tayo magkamali ulit. V minus VC over R. V minus, yung VC natin ay plug in ko na rekta, which is V, tapos plus V, distribute ko na para madali. R squared minus R. Okay? So, wala namang mali, no? Distribute lang natin. So, V minus V. V minus V. Tapos nag-negative siya. So, therefore, we have this guy. So, the power is just V squared. Tapos, over R na lang kasi makakancel yung isang R. And then, this is e raised to negative 2t over RC. Okay? Okay. And then, the total energy that is being consumed by the resistor is a divider here. Okay. Ano yung power? So, we integrate it all over all time. Okay. And then V squared over R tapos e raised to negative 2t over RC. So, this is just dt. V squared over R. Bibigay sa atin ito ay RC over negative 2. Then, I have to evaluate this guy from 0 to infinity. And this gives me, cancel na natin yung mga dapat i-cancel. So, negative CV squared over 2 na lang to. CV squared over 2. Then, this is just 0 minus 1. Same as before. And that tells us that yung pinakonsume ng resistor natin would be 1/2 CV squared. Amazing. Amazing. Amazing na sa resistor, hindi siya nakadependent doon sa resistance niya. So regardless kahit gaano kalaki yung resistance niya or gaano kaliit, it would be just dependent kung ano na lang matitira sa kanya mula dun sa capacitor. So yung capacitor, ninakaw kasi yung 1/2 CV squared. Matitira na lang sa kanya is sa resistor would be 1/2 CV squared na lang din. Kasi CV squared lang yung kayang give off ng source natin. Okay? Dali, no? Dali. Parang dali, diba? Okay. Now, syempre, mahirap naman kung yung mga power natin. Kapag sinusoidal yung natin, yung system natin, yung integral na to, it sometimes blows up. Nagiging infinity yung energy nung na gini-give off ng system kapag continuously giving off siya. Okay? Kasi sa capacitor natin, di ba, pag na full charge na ito, magiging open circuit na siya. So, napuputol yung circuit, napuputol yung delivery ng power nito. So, we have a finite amount of energy that is being given off by the source. Okay? However, in our discussions, lalo na sa mga digital systems, the power, the inputs are sinusoidal and continuous through time. Okay? They're continuous through time. So it would not be very wise to always integrate all over infinity sa time natin. Kasi things would blow up. Okay? So, ang kailangan natin actually is the average power. Okay? So, yung average power natin, defined siya sa amount of energy that is dissipated during some time interval. Tapos, di-divide mo yung power na yun by the time interval. Okay? So, calculate mo yung power, yung energy mo. Calculate mo yung energy mo. Tapos, at certain times, di-divide mo siya doon sa time na kung saan mo siya kinalculate. Okay? Okay. All right, let's try to understand this Let's try to understand this circuit. Itong makikita natin. So, ito ay kapag sinarado ko na yung switch, may current na magpo-flow here, and another here, tapos ma-charge up tong si capacitor. Okay? And then once I open the switch again, pinuksan na natin to, na full charge na to, no? So kapag na full charge na tong capacitor ko, tapos pinugot ko ulit yung switch, ang mangyayari, mag-give off naman siya ng current pa ganun. Okay? Okay. So let's try to buksan patay natin tong switch natin. Okay, open, close, open, close. Okay, so close muna natin, then i-open mo. Okay, so pag close, may dumadaloy na current. Diba? Ang sabi natin kanina, close to circuit. Kapag ginawa mo na siyang open circuit na. So, ganyan. Ito yung gagawin natin for this case. Okay? Then, denote natin yung time 1 as yung time na switch ay closed. Okay? And then time 2 would be switch ay open. And then, we call that the total time t. Okay, so let's calculate the work done here and work done here. Okay. So for simplicity, i-assume natin that in our case, itong time t natin, itong t1 and t2, are long enough para maging steady state yung capacitor natin. So ibig sabihin lang ng steady state is that yung capacitor mo ay umabot na siya sa parang full charge niya and umabot na siya sa kung discharging naman siya sa fully discharged state niya. Okay? So meron tayong graph. Water charging, may ganyan kang graph. So, at this, in-assume natin na yung time interval natin would linger around here kung saan diretso na yung line. Okay? Okay. Okay. So, yan, yung sabi natin, by definition, energy divided by time. Okay? So, sa atin, energy, W over T, this solves our problem. Then we just have to break it down from W1 and W2. Okay? Okay. So let's try to break our system down. So first things first, muna tayo at 1. So at region 1, kung saan switch is closed. Okay? Switch is closed. Ang itsura ng circuit natin would be something like this. Let me just flip it up. Okay, R1. R1. C. And then this is R2. Okay. So, syempre, huwag tayong magpapanik. Ang gagawin lang natin is to simplify our circuit to become something like this. So, we want it to be something simple. Okay, pag nagawa na natin to, pwede natin invoke yung mga equations natin na alam natin. Okay, so gawin natin itong Thevenin equivalent circuit kasi ito yung pinakamadaling for this example. Okay, so I just disconnect this okay, para hindi tayo para hindi malito yung iba. Let's do this slowly. Okay, since si C ay parallel with R2, pwede ko silang magbaliktarin without grave implications. So, para madali sa imagination natin kung paano yung mangyayari. Okay? Okay, so we have this. Okay, and then I will disconnect this C. Wala na siya. So we have this. Now we can do our Thevenin process, the process of getting the equivalent Thevenin resistances and voltages. Okay, VTH is very easy. VTH is very easy kasi voltage divider lang to. So we have R2, R1 plus R2, then times V. Okay, and then RTH, I turn this source off. So we have this R1, R2. So in these terminals, kung titingnan mo anong resistance nito, so that will be R1 with parallel with R2. R1 parallel with R2. Okay? Solve pa ba natin ito? Sige ako na. Hindi, solve natin para ano. So this is equivalent to 1 over R1. It's 1 over R2 inverse, and that gives me R1, R2, R1 plus R2. Okay. So this is the RTH and VTH. Did we get that right? Okay, get that right. VTH. And then, what's next? What's next? Kunin natin yung... ito. Okay na. Kakabit na natin yung C. Kinabit na natin yung C. Makukuha na natin yung... makukuha na natin yung dinidissipate ng system natin. Okay? Now, since nakuha na natin Thevenin natin, madali na natin makukuha yung voltage across the capacitor, di ba? Let me do that. So, VC would simply be VTH charging, di ba? Charging. So, 1 minus E raised to negative T over RTH times C. Okay? So, let's close it down. Okay, so this is the the voltage across the capacitor. Now, kukunin na natin yung mga energy dissipated dun sa system natin. Okay, so sino yung mga energy na nagde-dissipate sa kanila? So that would be the resistors, okay? So sila yung nagko-consume ng energy. So kailangan natin makuha yung power dissipated by R1 and R2. Can we get that from RTH? No, hindi natin pwedeng kunin 'yon kasi si power is square dependent. Okay? So siya ay P is equal to V1 squared over R1 squared. V squared over R. So yan. And then plus yung sa V2 naman R2. Okay? So since square sila, hindi sila bound by superposition ng okay? So hindi pwedeng si RTH yung gamitin natin. Babalik tayo doon sa una nating system. Okay? Okay. So ayan, kailangan lang natin kunin yung mga voltages that is running across your resistances. Okay? Okay, so for R1, we have V squared over R, diba? So, ang V squared niya would be V minus VC squared over R1. Tama? Dito, V times VC. Tapos, kabila naman would be VC squared over VC minus 0 yan, diba? Pero, huwag na natin pahirapan sarili natin. Okay, so kung tinry mo, no, kung RTH ginawa mo dyan, yung lalabas. P over T, P of T, then V minus VC over RTH squared. Tapos ito ay ni RTH natin. Okay, this one. So V minus VC squared R1, R2, tapos R1 plus R2. Okay, and this is not equal to this. Okay, hindi siya equal dito. Kulang siya ng term. Okay, so this is wrong. Okay, so this is wrong. All right. Okay, so let's continue. Plug in na natin si VC dito sa mga values natin. Okay, so this is actually a very long equation. V minus VTH. V minus VTH. Let me call this let me write this down for brevity lang para hindi tayo mahirapan magsulat. EXP. So this is VTH EXP and then squared all over R1. So wala na, sinulat ko lang ganun para hindi ako mahirapan magsulat. Then VC squared is just VTH EXP squared. And then R2. Okay? Alright. Tama. Tapos, gusto natin makuha yung energy that is being lost, that is being consumed. So, we integrate. Lagyan natin ng boundaries para tayo mahirapan. So, I have W that is 0 from T1. Okay? Kasi yung 1 lang kinukuha pa natin. W1, that is equal to P. Lagyan natin ng 1 din para tayo lost. Okay, so ito na mismo yung lalagay natin. Okay, so Control C, Control V. Para tayo mahirapan mo. Tapos D. Okay? And we just have to expand this exponential mamaya. Okay? But I think mas madali kung i-ano na natin. I-expand na natin itong mga ito para tingnan natin kung sino yung pwede mag-cancel out. So let me try to do that para mahirapan. So this is V squared minus VTH two V times VTH EXP, then plus VTH squared EXP squared over R1, and then plus VTH squared EXP squared R2. Okay? R2. So let's combine these things. Natin kung mas madali. So all over the denominator is R1 and R2. And then V squared R2 plus minus 2V VTH R2 EXP, and then plus VTH squared R2 EXP squared, and then plus VTH squared R1 EXP squared. So, in essence, pwede ko magpagsama-samahin yung mga so this is all this constant ng mga to. Lagyan natin parenthesis. EXP. So that's one. And yung isang integrate natin. And then another one would be combining the two. Kasi may EXP squared sila. So let's have it. VTH squared. Then R1 plus R2. Tapos EXP squared. Okay, I think this is easier for us to work with. Okay, kasi integrate lang natin si EXP squared tsaka EXP. Okay? Okay. So let's do that. Integrate natin si EXP squared. Okay, so 0 to T1. So that gives me 1. Ano yung nilat natin as EXP? 1 minus E raised to negative T. E raised to negative T over R PHC. Okay, and then D. Okay, and then this is just equal to, may natin x squared na ito muna. So this is just T minus plus RTH C times E raised to negative T over RTH C. Okay? Okay, may minus kasi dito, kaya nawala yung isang minus. And then these are all evaluated from 0 to T1. Okay, and then this is T1 plus RTH C e raised to negative T1 RTH C. And then minus yung evaluation at 0. So this gives me 0 yung first term and then minus RTH C ay RTH capital C. Tapos E exponential evaluated at 0 is just 1. So this gives me T1 plus RTH capital C I think mas maganda kung factor out yung negative. Tapos, this is 1 minus E raised to negative T1 over RTH C. Okay? Okay. So, next would be the other one. Evaluating yung ano naman, EXP squared. So, lagay na natin siya as EXP squared. Okay? So, yung D EXP is just derivative ng EXP would be 1 over R PH capital C e raised to negative T RTH C D. Okay, mas madali ba to? So, dt is equal to, okay, mahirap tayo. Papakahirap pa tayo pag ganito. Hindi, joke lang. So, dali pala to. Wait lang. Okay, mukhang mas hassle tong way nito. So, let's just expand. Expand na lang tayo. So, dali. So, exp squared is just 1 minus 2 e raised to negative t over r ph c. Then, plus e raised to negative 2t rph c. Okay, all level integrated with respect to dt. Okay, so let me have this t. Then plus 2 rph c e raised to negative t over rph yan c. And then the last term would be minus. Kasi merong extra terms, negative over 2. And then e raised to negative 2 over rthc. Okay? And then all evaluated from 0 to t1. Okay, so the t1 is very straightforward kasi plug in lang. t1 plus 2 rth capital C e raised to negative t1 over rth c minus rth c over 2. So, evaluated naman 2t1 rth. Haba, no? Papagod. And then minus everything that is evaluated with 0. Okay, so this is a constant, this is a constant. So minus 2 rth, 2 rthc plus the other one is rth c over 2. So we can simplify this further as something like this t1 plus, okay, gawin natin minus ito. So t1 minus 2 rthc. So that is 1 minus t is negative t1 over rth thc. And then the other guy is plus rth c over 2 plus 1 minus the exponential, which is negative 2 t1 rth c finally. Okay, so I have this, guys. Okay, so nasolve na natin yung dalawang kailangan natin, which is yung exponential squared tsaka exponent. Okay, therefore we can now write w1. So w1 would be integrating everything 0 t1 okay, factor out ko yung para tayo mahirapan, yung 1 over r1 r2, okay, 0 to t1 ng v squared r2. So that's d tau. And then the second term would be negative 2 V VTH, 2 V VTH R2, and then exponential, integral of the exponential, which is we know already, dt. Then lastly, plus factor out muna natin yung VTH squared R1 plus R2. VTH squared R1 plus R2, and then the integral of exp squared dt. Okay, so straightforward naman. And then I just have this. Okay, straightforward yung integral ng first term kasi v2 r2 t1. Tama? Kasi 0, wala naman yun. Minus 2v vth r2. And then I have here yung nasaan yung exponential lang natin. So let me just grab this guy. So ito yung sa natin, integral natin. For the exp. Yan. And then let's continue. The other one would be plus b squared th r1 plus r2. Okay, and then we plug in yung solve natin kanina, which is this guy. Okay, I think we got it. Haba. Grabe. Okay. So yan, then another one to close it all. Tapos, we just simplify this. Makuha natin si W1. Good Lord. How did, paano napunta dun yun? Okay, let's all combine the constants. I think we can do that. So the constants are would be R1 over R1, R2, V2, R2. So kinukuha ko lang lahat ng constant no? Minus 2V, VH, R2, T1, plus 2V, VH, R2, RTH, C. Ay, what did I do? RTH, C. So, wala tayong kinukuhang exponential. So, this is that term. Times this. So, kailangan positive siya. No? And then, let's continue. Plus VTH. VTH squared. R1 plus R2. Times T1. And then, we also use this for the other terms. VTH squared R1 plus R2 times 2 RTH C. And then the other one, the last one would be this term. So VTH squared plus VTH squared R1 plus R2 tapos RTHC let's see over 2. Okay, so positive, positive, okay. So these are all the constants. I think we can further simplify this by having the amount, the value of VTH, which is VTH is may R1 may ano siya R1 over R divided siya by R1 plus R2. So with that, so this is equal to 1 over R1 plus R2 B2 B2. What may B2? V squared. Yan. V squared to dapat. So V squared yan. Sorry guys. Okay. Let's have it. V squared. I think this simplifies nicely. V squared R2T1 minus 2. Plug in natin si VTH which is just V squared R2. So V times V, di ba? So, tapos may R2 siya. Then all over R1 plus R2. Then squared na to kasi may extra pa. P1. And then plus this guy is 2 V squared R2 squared RTH C. This is R1 plus R2. I hope they cancel out with each other. So this one is V squared. Tapos R2 squared. Tapos yung sa denominator, R1 plus R2 na lang kasi squared dapat to pero may extra term sa ganito. So, that cancels out. Okay, so I think this nicely mutes out the isang ano dito, yung isang term dito. Okay. Nice. Then this guy, minus V squared R2 squared. Ganun ulit. R1 plus R2 sa baba. And then 2 RTH capital C. And then, dito yun. Mukhang maka-cancel out na to, no? Maka-cancel out niya. So, lagyan na natin ng cancel out. So, 2V squared. That cancels out with that. Cancels out with this. And then, lastly, plus VTH squared. And then, ganun pa rin, V squared R2 squared. Tapos, R1 plus R2. And then, RTH. This doesn't cancel out nicely. Okay, so we have this. Okay. Tama ba to? Ano ba yung ginawa natin dito? Okay, so this becomes 1 over R1. Haba naman ito. V squared R2 V1 minus isa na lang to. Let me just double check this. 2 talagang 2 ano siya, 2V. Kasi expand lang natin yung so where did that come from? Dito, okay. Okay, makes sense. Okay, so going back. So there's nothing we can do about it. Bawasan natin ng isa. Gets naman kung bakit, kasi dalawa ito. So this is v squared r2 squared t1 all over r1 plus r2. Okay, and then the last term would be plus v squared r squared. V squared r2 squared RTHC all over 2 times yung R1 plus R2. Okay, so yan. Okay, how far are we? How far are we from the answer? Oops, sorry. Okay. So, ang next in line naman natin would be adding all those exponentials. Okay, exponentials tayo pupunta ngayon. Okay, so sa exponentials naman tayo titingin ngayon. So, yung ito, sige, sulat natin. Parang tayo mahirapan. Exponentials. Exponentials. So, first things first is this guy. May ganun pa rin. May 1 over R1 and R2 times negative V VTH Rs over R2. Okay, I think, sige, kayo na to. Simplify na lang natin to. Simplify na lang natin muna yung constant. And if it turns out na tama yung first term natin, then probably we have done things right, and then we are going to produce the second term. Okay. Okay, so let's do this, I think. Okay, so distribute na natin to 1 over R1 and R2. So we have V squared T1 over R1. Okay, is that good? Is that good for us? Okay, denominator I R1 plus R2. So it's not looking good for us. But I think we can proceed. Next would be here, V squared R2 T1 tapos R1 plus R2. And then R1. Tama na. Okay. And then plus V squared R2 squared RTH C to R1 plus R2. Tapos R1 and R2. Okay. Hindi ko muna siya cancel. Okay, so we have this. Pagsamahin natin itong dalawa. Maybe we can shed some light here. So the denominator is R1 plus R2 R1. Okay, so nothing happens to the second term. And then sa kabila meron, so V squared T1 R1 plus R2. Okay. So from here, makikita natin that we could cancel out yung mga R2 sa numerator. So ito, tsaka yung isa dito. Okay, so V squared T1 R1 survives, and then the rest will die out. Tapos sa denominator, R1 plus R2, R1 cancels out. Then this is the term without the capacitance, R1 plus R2. Okay? So is that what we have obtained? Okay, so yes, V squared T1 tapos all over R1 plus R2. Oops. I think napalaki yung sulat ko. Okay, so this is V squared T1 R1 plus R2. Then if you would proceed in doing the other terms, you will get masyadong naubos oras natin. You will get the second term to be plus CV squared over 2 CVTH squared. Then multiplied by some factor 1 minus E raised to negative 2T1 over RTH over C. Yan. Ito yung lalabas na term. And then if you would approximate time T1 to be very large, this would become very small. And ito na lang yung matitira. Okay? Pag malaki yung time interval T1 mo, ito yung matitira. Okay, so that's it for the W1. Medyo mahaba siya, pero you can do it. You can do it. Always do it. And then for the second part, W2, ano mangyayari? Magbubukas yung magbubukas yung switch natin. So, ang circuit mo lang would be very simple. Capacitor in parallel with a in series to with a resistor. Okay, so this is fairly simple. Alam mo na agad yung dissipated power doon sa dissipated energy through the resistor, and that is 1/2 CV squared. Okay? Bakit VTH yung gamit? Kasi yung VTH yung na-store sa kanya. Yung VTH yung na-store na voltage sa kanya. Okay, so i-dissipate niya lang yun. Okay, so you have this straightforward, and then you could combine these two. Pagsamahin na natin sila. Okay, so the P average is just V squared T1 plus R1 plus R2. Gamitin natin itong this guy, kasi na-assume natin na yung times natin is larger than the time constant. CV squared over 2 plus another CV squared over 2. So that is just 1. And then this is all over the time, total time, T. So the average power would become V squared T1 R1 plus R2 yan, T plus CVTH squared over T. Okay? So this is your So meron tayong tinatawag na static power and the dynamic power. So yung static power would be those that terms without capacitance and inductance, and those dynamic power would become those terms na merong capacitance. Syempre. Okay? Okay. So yung static power, it's like the dissipated power of the system kapag pinatay mo yung mga capacitors and inductors. Okay? Okay. So, pag pinatay mo to, yan yung parang dinidissipate at time t1. Okay? Okay. Okay, let's proceed. Let's proceed. No? Basically, ganun lang gagawin mo. W1 plus W2 divided by total time. Okay, so meron tayong tinatawag na static power dissipation. Yung kanina, pinakita natin. P static, which is just the power loss sa static or continuous na current na binibigay ng power supply. Okay? So, yung dynamic naman is the power loss due to the switching currents. Kapag nagdi-discharge and charge ka ng capacitors or inductors in any case. Okay. So, sa static power dissipation natin, gagawin natin is usually, ginagawa natin para makuha ng static power dissipation is we remove all capacitive and inductive elements. So, yung capacitors, gagawin mo siyang open circuit. Tapos si inductive naman, gagawin mo siyang short circuit or just wire. Okay? So, worst case static power dissipation. Ibig sabihin lang nito, lahat ng elements mo nag-dissipate ng power. Okay? So, lahat nag-dissipate ng power. Okay. So, example dito would be this guy. Mangyayari is that kung gusto natin kunin yung static power dissipation nito, gagawin lang natin would be bubuksan natin lahat ng yung mga MOSFET natin so that meron silang dinidissipate na power. And this is simply static. This is just V squared, which is Vs minus 0. So Vs over V squared over R lang to. So yung total resistance will be RL. And then plus RA parallel with RB in parallel with RC in parallel with RD. Okay? So yan. So yan siya. So this is the static power that we dissipate. So maraming way para makuha yung pero ang gawin natin worst case static power dissipation. Okay, applicable kaya yun dito. So, try natin apply dito, no? Pag pinatay natin to, the short circuit lang, maging open circuit lang to. So, V squared over R is V squared over R is over R, total R is R1 plus R2. Tinatry ko lang, no, kung mag-apply kaya to. Kasi approximation tong ginagawa dito. Pero, ayan, try natin dito. Tapos, okay. So, hindi siya nag-ano, no? Weird siya. Okay, anyway. Anyway, let's try to do one more example. Hindi natin isipin yung kanina example. Ayan. So, try natin tong inverter ngayon. We have this inverter. Tapos, meron tayong tinatawag na load capacitor, which is attached here. Okay? So, meron tayong dalawang state. Kapag nakapatay si MOSFET mo, so that is Vin is low, VGS mo is mababa. Bumaba yung Vin mo. So ito ay parang graph ng voltage. Ang mangyayari is that yung VS mo, yung voltage source, will charge up your capacitor kasi walang dadaloy na current dito sa MOSFET mo. So dito siya dadaloy sa capacitor mo. Okay? And then kapag tumaas na yung voltage, goes up, ang mangyayari is that the MOSFET would allow current to pass through. So magdi-discharge si CL, may dadaloy din na voltage, may dadaloy din na current coming from VS towards this path. Okay, so again, meron ka lang dalawang state. That would be the time, yung energy dissipated at T1, so W1 yun. That would be, pili ka lang kung anong gusto mo dito. No? Pwedeng maunahin mo si Vin, unahin mo si high na Vin or low na Vin. Okay? Okay. I think we can do a bit of a calculation here. Okay, so in our case, try natin na yung W1 is yung high input. That means bukas yung switch mo. Dumadalo yung close yung switch mo, sorry. Low input. Okay. I-set up ko lang itsura ng circuit natin. So for high input, ang mangyayari is that ganito itsura ng circuit mo. You have your voltage, your VS here. Tapos meron kang RL. Tapos meron kang R-on. Okay? So may resistance to. So ang gagamitin nyo is switch SR model na. Kung walang given na model na sinasabi. Pero usually binibigay naman yung model. And then the capacitor is there, and then you do your Thevenin equivalent. Circuit. So this becomes RTH would be parallel si R-on at RL. Saka may kakabit capacitor mo. And then si VS would be the voltage VTH, sorry. VTH is your V times yung R-on. Tapos R-on plus RL. Okay? Gets naman yan kung bakit naging ganon. Okay, so that is for the high input. Ibig sabihin nakabukas yung, nakasarado yung switch. Nakalito yung convention. Okay, you have that, and then you can go again to proceed in calculating your calculating the power, that is energy, dissipated by that system. Okay, so gawin pa ba natin? Hindi na natin gagawin. Pero ito na yung simplification, tapos babalik ka dito, which is yung kanina example din. Okay? So yung results kanina, magagamit mo rin dito. Okay? Okay, balikan ko pala yung kanina, no? Sinasabi ko na worst case static power dissipation, gawin natin for this case. Ano yung nakuha natin? Ano yung ginawa natin? Sorry, ito. Okay, so papatayin natin yung capacitor, tapos kunin natin yung power dissipated, so that is P is equal to V squared over the total R, which is just a series. Okay? So sabi ko kanina parang mali yata to. Yung parang hindi ko nakukuha kanina. Okay. So therefore, yung um, tawag dito. Yung average power, ay average, teka. Ayan, balik tayo dito. Ito na lang yung gagamitin ko. So yung energy, di ba, ano siya? Sige, going back. Sorry. I'm lost. P, V squared over total R, R1 plus R2. Tapos, kapag gusto natin yung W, P times T lang. So, in our case, R1 plus R2 T1. Ayan, palabas ko na. Okay, and then the average power, static power dissipation would be W over the total total time T. Kasi sa kabilang at T2 naman, walang dumadaloy doon sa current natin, ay circuit natin. So, 0 lang yun. So, this becomes the average power, static power dissipation, would become R2, tapos T1 over T2, at T1 over T. Now, if symmetric yung time, yung hiwa mo ng time, T1 is equal to T2. T1 is equal to T2. Therefore, T1 and T2 must be equal to T over 2. Okay? Therefore, this is just V squared over 2 R1 plus R2. Okay, ayan. So, yes, tama siya. Tama yung process. Nalito lang ako kanina. P-static. Okay? Yes. Okay, so sundan nyo na lang sa libro. You can do it by yourself. Algebra lang siya. Maraming addition, maraming subtraction, and just integrals of ano lang. Again, lalabas dito sa term na ito ay ito talaga. Okay? And then for the other term dito, lalabas naman dyan is somewhat exponential. And then you somewhat like this lang din. Okay? Tapos, ayun, as the time is larger than RTH over C, ma-simplify mo siya sa ganito. Okay? Okay. And as you can see, no, dito sa part na to, yan, parehas lang din siya sa nakuha natin. Okay? And then, the next one would be W2. And this is not very simple kasi what is yung itsura ng state natin kapag W2? Ito, no? Charging siya. So, yung una kanina, ito. Okay? So, ginawa natin dyan. Ito yung equivalent circuit mo. Okay? Ito yung equivalent circuit mo dyan. Then, kapag papunta ka na dun sa kabilang state, which is this, lalabas naman would be this guy. Okay? Okay. Now, these two terms, itong second term here and this term here, meron silang exponentials dyan. Okay? Hindi lang natin sinasama kasi sabi nga natin, kinukuha natin yung energy in a time interval such that steady state na yung capacitors natin. Then again, pag pinotal na natin siya, ayan. Ito na ilalabas. Okay? Tapos, divide natin with total T para makuha yung average power. And then, makikita natin dito kung sino yung mga walang C, walang L power inductor. No? For in our case, C lang. Yung walang C, siya yung static power dissipated. Okay? And then, Yung may mga capacitance, inductance, wala inductance dito, ano lang, in general case lang. Sila yung tinatawag na dynamic power natin. Okay? So again, I suggest you try it with your own hands, yung process. Hindi na natin siya hinimay ng maigi kasi as you can see kanina, it takes time. Okay? So in your case, you just have to do it in a big paper para you're not lost. Pag samasama yung mga constants, kung gusto mo yung method na ginagawa ko kanina, wherein I have separated all the constants and constants na gusto ko. Okay? So nakita natin na yung mga walang C, ito siya. Tapos napalabas ko siya, ibig sabihin, medyo tama yung ginagawa natin. I'm halfway correct. So pag sasama-samahin ko na lang yung other terms, yan, nawala siya. Okay, anyway, that's it. That's it for this meeting. So, be ready for the exam. Bigay pa ako ng prob set para naman bonus prob sets para naman matry nyo by hand itong mga process na ginawa natin dito. Okay, so thank you. Have a nice day.